Hello, Geometry Semester 2 students. I wanted to take a quick moment to give you a little bit of a deeper dive into our 30, 60, 90 triangles and our 45, 45, 90 triangles. So we'll start with the 30, 60, 90, and I want to show you why you get that weird root 3 relationship with this particular one, and then that weird root 2 relationship with the other one. It actually just comes down to the Pythagorean theorem. We know that's a squared plus b squared equals c squared. There's going to be a part of this that's going to be just arbitrary. That just means I'm picking a number. There's a reason for it, which we'll get to later in our course. But for right now, it's going to seem kind of random. Based on these rules, if you have a 30, 60, 90 triangle, and this shortest side happens to be a 1, that guarantees, for reasons we'll get to later, that this is a 2. This is the part that people might wonder about. Why in the world is that part root 3? Well, if we look at this side we could call A, this side we would call B, and then this long side, hypotenuse, which is 2, would be our c squared. So if we plug all this information into the Pythagorean theorem, that tells us why we get root 3 here. Let me show you that. So this would be c is 2, so 2 squared equals, this is a, so that's 1 squared, plus, we don't know what this side is, let's call it b, equals b, so that would just be b squared there. So if we do the algebra to find out what b is, this would be 4, this would be 1 plus b squared. If we subtract 1 on both sides, we get 3 equals b squared. And now b, this side that we're after, is, well, it's root 3. If we take the square root of both sides, we get root 3 equals b. That's why this is root 3. So importantly, you may not have understood everything I did or why I did it, but I want you to see that it just comes back to the Pythagorean theorem. The important part is that we started with a 1 here, a 2 here, and that made that a root 3. Now let's take a look at the 45, 45, 90 triangle. This isn't, by definition, an isosceles triangle. Isosceles triangles have the same two angles here, and this one just happens to be a right triangle. Remember a moment ago, we just sort of randomly picked the number 1 to be the size of one of our legs. We're going to do that here, and we're going to assign this a value of 1. Now, if this is an isosceles triangle, that means that this being the hypotenuse, this leg has to be the same length as this. That makes this length a 1. So we're going to use the same rules. This would be A, this would be B, this would be C. So the Pythagorean theorem looks like this. A and B are both 1, so this would be 1 squared plus 1 squared equals c squared. The hypotenuse here being C. So 1 squared plus 1 squared, well, that's just 2. So c squared equals 2. That means that this one, the long side, is just root 2. So that is where that root 2 comes from. Now you might be wondering, well, in her video she said it was x. For example, if this is x, then this is just 2x, and this is x times root 3. That's true. All we'd be doing there is scaling this up. So for example, if this side length wasn't 1, but let's say it was 5, then this side length would be 2 times 5, or 10. And this side length would be 5 times root 3. We would just leave that as 5 times root 3. The same is true here. If this was x, and this was x, this just becomes x times root 2. The beautiful thing about triangles is you can scale them up or scale them down by multiplying by x, and these proportions all stay the same. So at the heart of all of this, why do 30, 60, 90 and 45, 45, 90 degree triangles have these special relationships? It's all because of the Pythagorean theorem and the rules that mean that triangles have to add up to 180 degrees. I'm hoping that makes some sense for those of you that were curious. We don't want this to seem mysterious to you guys. There's good reasons why these rules are the way they are. Thanks.